In a study of 11,000 car crashes, it was found that 5,676 of them occurred within 5 miles of home based on insurance company data. Use a 0.01 significance level to test the claim that more than 50% of car crashes occur within 5 miles of home. So if we were to draw a picture of this situation, we're testing a claim that the population proportion is greater than 0.5. It says here we're going to test that more than 50% of car crashes occur within 5 miles of home. So we're testing that the population proportion is greater than 0.5. Now, if our sample statistics landed anywhere to the left, that certainly wouldn't support that the population proportion is greater than 0.5. If our sample proportion landed a little bit to the right, it wouldn't necessarily convince us that the population proportion is greater than 0.5. So we're going to, right here in the middle, mark this as p equal to 0.5, and then put our critical region over here to the right. If our test value that we generate using these statistics, so in other words, if our statistics land way up here to the right of this curve, to the right of this z-critical value, we would believe that the population proportion is greater than 0.5. So our hypotheses then will look like this. P equal to 0.5, P greater than 0.5. If we land way up here, we will reject the null hypothesis and conclude that the population proportion is greater than 0.5. So we need to write down some of this information here. We're told that the sample size was 11,000. There were 11,000 subjects in the study. And of those 11,000 crashes, X, the number that satisfy this criteria, in other words, that were within 5 miles of home, was 5,676. Now, we need to come up with a critical z value here, and we will do that by looking at our significance level. It's 0.01. So alpha is equal to 0.01. And we can get this critical value from StatCrunch. So we'll push StatCrunch, stat, calculators, normal. Now, we want a right tail test, so we're going to find a critical value. We're going to put greater than or equal to, and we're going to make this 0.01 as specified in the problem. Now this is going to give us a z value of 2.33 if we round to 2 decimal places. So this z critical value then is 2.33. And what we'll state here as a decision rule is if our z-test value is greater than 2.33, we should reject the null hypothesis. We would reject that the population proportion is equal to 0.5 and conclude that it's greater than 0.5. So now we need to generate a z-test value. And we can do that using StatCrunch. We'll push stat, proportions, one sample with summary. The number of successes was 5,676. The number of observations was 11,000. We'll hit next. Hypothesis test, and that null proportion is 0.5, and that's what we have here, 0.5. We'll make sure that our alternative hypothesis says greater than, and then we'll hit calculate. This gives us a test statistic of 3.36 when we round to 2 decimal places. Now this z-test value is larger than 2.33, the z-critical value. So our conclusion then would be to reject the null hypothesis. And we would say something like sufficient evidence was gathered at the 0.01 level of significance to conclude that more than 50% of crashes occur within 5 miles of home. We would also draw that same conclusion if we look at the p-value and alpha. The p-value here is 0.0004. Now that is less than 0.01, which is what we had for alpha. So since the p-value is less than alpha, we would reject the null hypothesis. So let's follow through with the parts of this problem. Our hypotheses that we designed looked like this: p equal to 0.5, p greater than 0.5. Our test statistic was 3.36. The p-value was 0.0004. Now we need to state a conclusion. We would either say that there is sufficient evidence to support the claim that more than 50% of car crashes occur within 5 miles, or there is not sufficient evidence. Well, we've already stated that. We stated that we did gather sufficient evidence to conclude that more than 50% occur within 5 miles. So that's the first choice. Are the results questionable because they are based on a survey sponsored by an insurance company? And we'll select the results might be questionable because the sponsor might have a self-serving interest in the results.